Right, welcome back everybody to the third video in the series on CSEC quadratics. Good. So far you all probably got accustomed to um my not too good handwriting, right? Only one complaint I get from my students, and that is more of a jest in that the students tend to make fun of my handwriting and tell me that I have my own font. But other than that, by now you all will be going through the videos and you can feel free to ask any questions at any point. So now this is where the little bit more challenging part comes in, where we're talking about something called factorization. Right now, um, a factor, right? A factor of a number, right? If we think about what a factor is, a factor of anything, like we say, what is a factor that leads to global warming, right? A factor that leads to global warming is something that um, contributes to global warming. So if we think of a factor of a number, a factor of a number is a number which contributes into building the original number. So it's a number which can, if we think about it from the division aspect, which can divide another number or the original number, another number exactly, right? That means with no remainder, right? So if I say, for example, right, factors of 30. These are 1, because 30 divided by 1 is 30, 2, 3, 5, 6, 10, 15, and 30. I think I'll leave out any there, but you know, these are all numbers. And I'm gonna put equal here. I can put equal to, put the set around it, right? These are all numbers which can divide 30 exactly. So factorization, when we deal with factors, we deal with something that can divide something, and one number that can divide another number exactly without leaving a remainder. So when we deal with factorization, right now, this to have a fixed definition, right? At this level, what we will deal with factorization. Factorization is the process, right? It is a process. It's the process of breaking up a number, of breaking up, and not just a number. We could put an algebraic term. And algebraic, right? Don't let it scare. Algebraic just means algebra. We're talking about using variables to represent quantities, right? An algebraic term into its factors, right? Now, into its factors, right? So when we say into its factors, we mean into at least two numbers that multiply to give it. So if I say, for example, factorize 30, factorize 1, let's go with, 20. Factorize 20. Factorizing 20, I just break up 20 into two numbers that multiply to give me 20. So 1 and 20. Yeah. It could also be or 2 by 10 or 4 by 5. These are all factors of 20. It don't have to be 2, but for simplicity purposes, we look at our numbers that multiply to give you 20. Good? So let's go with 2. Now let's think about x. What can multiply to give us x? Right? We are thinking about basic whole numbers or integers, right? Integers are essentially negative whole numbers, 0 and positive whole numbers. So x, the only thing that can multiply to give us x is 1 and x, right? Nothing too bad there. Let's go with 3. Let's see. Let's go with 5p. What can multiply to give us 5p? Now, something to remember is that 1 is always a factor of every number. Keep that in mind, right? So note, right? 1 is a factor of every term, right? No matter what, even 0. So 5p, We know that 5 multiplied by p will give us 5p. This is a factor of 5p. This is also a factor of 5p, right? Similarly, 1 is a factor, but 1 by what will give us 5p? 1 by 5p is 5. Good. So let's go with one more. Let's go with um, 3m squared. Now, as the powers get larger, you have to start thinking a little bit more. So simply enough, 3 by m squared is 3m squared. Good. Now, also 1 by 3m squared is 3m squared. Right now, what else? What else could give us 3m squared? You can pause the video and think about it for however long, and then unpause the video when you think you get your answer. So after the pause, what else could we combine to give us 3m squared? What two numbers, right? If we take 3m and multiply it by m, wouldn't that also give us 3m squared? Yeah, 3m by m by m is m squared. Yeah, so this is how we have to start thinking about terms now, right? So we're not thinking in fractions and things. So something to consider when factorizing, we can find one factor by dividing by a known factor, by a known factor, right? So for example, right, factorize 4p, right? So if we're factorizing 4p, right, we want to break it up into at least two factors. So factorizing 4p, we know that 4 is a factor of 4p. So how do we get the other factor? We take 4p divided by 4 and that will give us p. The 4's will cancel to give us p. So we know that two factors are 4 by p, right? What about 2? If I take 4p and divide it by 2, 4 divided by 2 is 2, so this will give us 2p. So basically 2 by 2p will give us 4p. So that's another factor, 2 by 2p. So division is a big part of factorization, right? 1 is a factor of anything. 1 by 4p will give us 4p, right? And these are essentially it. So when we are factorizing, division is a good part of factorization. Right now, this is just your first one. We're going to be doing factorization for a while. This is basic factorization we are dealing with. So now we have to start thinking a little bit more along the sides of combined terms. So let's see if I ask you to factorize 1, 3x plus 6. Now we have to think, once you see this addition or subtraction, you have to think of a number or a term which could divide both 3x and 6. Right? So let's see what that could be. I know that 3 could divide both 3 and 6. Good? So let me show you what we do. I know that I have to take 3 and multiply it by something to give me this. So factorizing do have to be a hard process. 3x divided by 3 is x, plus 6 divided by 3 is 2. Now, is this factorization? Isn't this two terms, 3 and x plus 2, that when you multiply them out will give you back 3x plus 6? 3 by x is 3x, 3 by 2 is 6. We have factorized 3x plus 6. And this are factors of 3x plus 6. Right, let's go again. Let's go with 5p minus 20. What could divide both 5p and 20? 5 could divide both 5p and 20. So 5 multiplied by what will give us 5p. So you take 5p divide by 5 and this will give us p. And 20 divided by 5 is 4. So this gives us 5 by p minus 4. You don't need to have the multiplication sign. You can leave that as is, right? Or you can remove the multiplication sign. Good, let's go with number 3. Let's go with 8m plus 64. Now you think about it. What could divide both 8m and 64? 8 could divide both 8m and 64. So 8m divided by 8 is m, and 64 divided by 8 is 8. Right, and now let's put that on this side here. 8m divided by m. You can have a little working column in the questions, right? 8m divided by m, the m's cancel, and this will leave us with 8. Now, I know, again, teachers will be looking at this video as well, right? My fellow maths teachers, I know that you all will be teaching highest common factor and so on, and that's fine. I am just doing this to give people an overview of how to do factorization, right? So bear with me if it is I don't do the highest common factor or the greatest common factor of algebraic terms, right? There are just some ways we could make this CSEC quadratics course a little bit simpler for our students, right? So let's go to something a little bit more challenging. Let's go with 4a squared minus 2e. Actually, I'm going to change this. Let's put this as 6a squared minus 12e. So let's think carefully now. I am seeing a squared. Now I know a squared is a by e. So technically, this is 6 by a by e. So I have two e's multiplying by each other here. This is just one e. Right now I know 6 could divide both 6 and 12. So I will take out 6. Now this is two e's. This is one e. So the most e's that I could factorize is one of the e's. So a nice hint, right? A nice tip to note here is that we could only factorize, factorize the smallest power. The smallest power. Now, this is not a hard and fast rule. As people go up into higher levels, you could divide sure by any power that you want. But for this level, this is just a little tip to make things a little bit easier for you. Right? This is just a little tip on the side here. We could, well, we should only factorize the smallest power. We don't need to, right? But it makes it easier. So the smallest power here is 1. Right? Remember, a by itself means a to the power of 1. So remember, factorization is a process of multiplication and division. So 6a squared divided by 6e. Let's put that on the side. 6e squared divided by 6e. 6 divided by 6 is 1. E squared divided by e is e. Now, if you're not sure how I got that, message in the comments and I will guide you to a video that will show you division of algebraic terms. But this is one of the pre-knowledge topics of this year. Now 12e divided by 6e. 12e divided by 6e. 12 divided by 6 is 2. E divided by e is 1. 2 by 1 is just 2. So this will just give me 2 here. Yeah, and you don't even need to put the 1e here. You can leave it as just a. But if you put 1e, that's fine as well. All right, let's do another one very similar to that. Let's go with 7m squared. Let's go with 7m cubed minus 21m squared. So I know that 7 could divide both 7 and 21, and I take out the variable with the smaller power. So 7m squared. 7m cubed divided by 7m squared will just give us m, and 21 divided by 7 is 3, m squared divided by m is 1. So I don't need to put that 1 there, and that will give me my answer. 7m squared by m is 7m cubed. 7m squared by 3 is 21m squared, and the same sign in the middle here. So I will continue with this type of factorization in the next video, because it is crucial that we know how to do these, right? So I will see you all in the next video. You can look out for our worksheet at the end of session 4 based on this. So take care until the next video.